Okay, computer. When you were here before, I couldn't look you in the eye. You're just like an angel. Your skin makes me cry. You float like a feather in a beautiful world. I wish I was special. You're so fucking special.
Hey guys, welcome back to 1999.
But I'm a creep.
Hopefully I don't get copyright stuff kicked off. That was the great Richard Cheese. Anyways, had the OK computer in the beginning and I thought it fit well. And if he ever sees this video, he never will. But anyways, it's out of love, man. I dedicated a whole entire Mercedes-Benz build for you. It's no lie. I made okay money on that. Anyhow, all right. So this is the third part of a three-part series with a digital dash, right? Digital dashes are kind of expensive to buy. I wanted IAT gauge, and one thing led to the next, as I've gone over in the last two vids, right? So this one is going to be on the Arduino, and I've never touched an Arduino before until maybe a few months ago. I've never done any coding in my life. I've never done any of this stuff. As I've said multiple times, I'm not like an electrical guru, right? And I still don't even know how parts of this dash work. I'm just being real with you. And I'll explain why and how I get the concept of it, but I definitely wouldn't say that if you plop me down and was like, bro, here's an Arduino, here's the program, everything, and here's my gauge and here's the stats on the gauge, the specs on the gauge. Make a gauge. I'd be like, bro, I'm out. So I'm going to show you how to basically be as lightly put it, as ignorant as me, and how to get this into reality. And we're going to use a little bit of help, and I'll explain that. Right. So the first thing I did was I knew I wanted to use Arduino, right? Because you see it, Google it, whatever, images, stuff like that, digital dashes and all that stuff. And I bought a little cheapy kit like this, right? And I also read this book, which is good for the backstory of C code and C+ code and Arduino, and it has little tutorials on how to make stuff. And same with the kit. The kit actually is good to own too, because that will it seems kind of like a kid thing, and I understand. But if you've never done any coding or anything like that, I mean, you are a kid. Your brain is you have the knowledge of a kid with coding, and the kit actually is kind of cool. So it expanded my mind. It tells you how to download the Arduino IDE program to write the code. It gives you really simplistic instructions on how to write codes and get LCD screens to work, and why and how and all that stuff, using potentiometers. Potentiometer is basically a sending unit, right? It changes the ohms. This is the first gauge I ever made using that little kit. Clearly, I did not use that LCD, but that's the other thing. The kit comes with like proximity sensors, all sorts of stuff, and it was kind of mind expanding, actually. And I'll go over that towards the end of what we can do with this Arduino, way more than just gauges. And it isn't like, I mean, honestly, car manufacturers do the exact same thing. But like I said, I'll go over that later. So this is the first gauge I made using just a kit. The LED lights up when I'm at 15% fuel. My first dip of the toes into the hardcore coding and stuff was watching a guy named Upper, or Upper. I don't know how to explain that, or how to say his name. And if you notice, that gauge looks exactly like mine. That's because I copied it. I literally wrote down his whole entire code. I copied it word for word. If you get really into this, he has awesome YouTube vids. But yeah, I copied it word for word, literally. Not even gonna lie. He went into cotangent, tangent of how to draw the graphics, all that stuff. I just copied it. I tried to keep up, but I had a really hard time. So I ended up with that, right? So now I got some gauges. They're not really doing much, whatever. But that was my launch point. So then it was time to actually get everything, all the parts together, all the hardware. So hop online. This is all from Amazon. You can buy 3 nanos for $16. You're going to need an expansion shield. Actually, you don't need one. They sell nanos without the legs, so you can solder it, but ain't nobody got time for that. You're going to need a buck converter. This guy takes 12 volts or 24 volts in and pumps out 5 volts, 5 amps out. And your Arduino works on 5 amps, and so do the OLED screens. You're going to need capacitors. The 0.1 UF, or also they call 104. You need 2 of these per gauge. One on the back of the LED screen and one on the actual Arduino. This is what helps cut down the interference and the noise from the vehicle's ecosystem. You got alternators and spark plugs, and also you got a whole bunch of electrical things going on in there, right? You're going to need a resistor kit. You don't need that many resistors, but I mean, I don't know, $6, dude. Come on. Little jumper wires. All this stuff is like super cheap. The most expensive thing is your OLED screen, and these are $17 a piece. These are SSD 1309, so they're 2.42 inch. They have smaller ones. That's the SSD 1306. There's a whole bunch of different screens you can choose from, right? But that will depend on your coding. If you notice, I bought I2C 4-pin. I'll go over that in a couple minutes here, what the difference is. So basically, this is the wiring from the buck converter. This is how I wired everything. I had 3 nanos on each side of my dash, buck converter directly in the middle. So basically, it just kind of branches out, and I did that with the power and also the grounds. This is obviously just the grounds, obviously. You're going to want to go back to my old video about where I hardwired my dash and screen grab and print this off. Here I'll explain the actual wiring of the buck converter. I use the ignition on dash wire, which is the white, and it goes to the buck converter. It also, if you notice, goes to the voltmeter gauge. In this instance, that wire is kind of like a sending unit. We'll just call it a sending unit for ease of use, right? And then I tried to kind of explain how I branched off all those the positives and the negatives to each little Arduino, right? And so then you pretty much have this when you're done. They all light up. I'm missing a little Arduino, but whatever. This is how you wire the 4-pin OLED screen. You have the DA, which is the data, goes to the A4 pin. The SCL, which is they call the clock, goes to the A5 pin on all Arduinos, on all nanos, on this particular instance. VDD is voltage voltage something, V, voltage, there you go. That goes to the power. GND obviously is ground. You want a capacitor in there as close as possible to the screen. And like I said, those are 4 pins. You can also buy 5-wire and 7-pin. This video is just a launch off to whatever you'd like to do. You want to copy me like I copied Uper? Fine, go for it, bro. If you want to get more hardcore and have animations, then you want the 5 or 7 pin. Like, you remember in the 90s, 2000s, when JVC had like the dolphins jumping? yeah, that's nostalgia, man. Like Civic Si Blue. And anyways, some of us remember those years, and they were glorious. But you could actually do that with an Arduino on a screen. In that case, for animation and video, you want to use the 5-wire 7-pin because it's faster processing. I know that our gauges are the ones I use, but these gauges are technically animated. But the animation is slow enough that we can get away with 4-pin, and it's just a lot less wiring to deal with. But the program, as far as I understand, the programming is the same. So it's just a wiring situation, how much you want to wire. This is where I put in the capacitor, right in the plugs that go into the back of the LED screens. I didn't show it, but basically I ended up heat shrinking that to keep it all together, and it worked out just fine. Been driving around like this for a while now. I tried soldering and all that. It melted the plastic. It was a disaster. Anyways, that's the best I could find. If one of you guys know a better idea, let me know. So now we have the screens in. You won't see the capacitors here because this is for bench testing. And then I didn't realize until I was told that the interference, that's why I needed the capacitors on the Arduinos and the what's it called. But there was a lot of mistakes made, and I had to go back and redo, and it was like, what's wrong with this? And then, whatever. So I got like fuzzy screens and stuff, but I'm skipping I'm skipping the LMNOP part and trying to get you guys from A to Z, right? Because otherwise we'll be here for 2 hours. All right, so the wiring for the voltmeter, this is the most complicated one. Remember, the black and white kind of acts as a quote unquote sending unit. It's a feed to the AO. The A0 on all of these is what is taking in the data and to the nano and processing it and spitting it out to the screen, right? So use the ignition on wire because we don't want it reading the voltage when the Jeep's off. So you don't want the red wire that goes to the clock on the stock gauges, right? And the blue wire doesn't do us any good. No, sorry, I'm thinking audio, not the blue wire. The red and black wire, which is the dimming wire. Now, you can actually use the dimming wire on that, right? Into the Arduino gauge. And you can make it in a program dim and also make brighter. When you turn on the lights in your Jeep or your vehicle, you can make it so that it dims. And it would use that wire. It would just, you'd have to do another voltage divider, which is what this is called, with the 2 different resistors. Anyways, you can use it as a signal. I didn't do that, so you can research that on your own. I'm getting off topic here, but it is doable. A lot of things are doable with Arduino. It's going to blow your mind. I'll talk about it towards the end. So we use the ignition on, and the buck converter. That's also what feeds the buck converter. So you'll have a Y. You'll have one white black wire going to the buck converter, and then one going into this guy with a 10,000 ohm resistor and inline, and then also a 2.2 thousand ohm resistor from the ground of the nano into the same with the solder heat shrink connector, and then into the AO. Also, you see the little capacitor to keep down the noise, especially on this one because it's reading, has the quote unquote high voltage, whatever by it, the 12 to 15 volts or 14.5 volts wire. So yeah, so you have to, from the ground, say using the same ground as the buck converter. Arduino shares the same ground as everything else in the vehicle, right? All grounds are all the same. So inline is a capacitor, and then that goes to the AO as well. So yeah, it's kind of weird when you read this. You're like, you've literally been told never to have a positive and negative wire touch, but there's a capacitor in between here and resistors, and so it changes things, right? But if you're not good in electronics, that's like what you always hear. Anyhow, so here is the actual one. If you want to look at it, this is my actual voltmeter gauge. Kind of ugly. You see the heat shrink wrap. You see the where it splices off. You see the screen plugged in. All that stuff. And I'll go over how I did the heat shrink wrap for the little capacitor and the resistors. Right. So here is the oil gauge. The blue wire is oil gauge. This one is wired differently than a voltmeter. Voltmeter is its own wiring. Has that, again, voltage divider. You can Google that and see what it does, how it does it, all that. So this one is the oil sending unit, which is just ohms, variable ohms. That's how a sending unit works. This oil sending unit works from 0 to 90 ohms. And then from the 5 volts in from the buck converter, splices out, and then goes to a 100 ohm resistor. That's called a drop down resistor or a pull down resistor. I forgot which, but I'm barely grasping this stuff. And then I have a capacitor again to cut down the noise, right? And then that goes into the AO. Again, AO is what reads it, kicks it out to the screen. And then you see from the buck converter, the 5 volts and the to the OLED screen, right? And here is my actual one. So if you want to study that a little bit, screen grab it. Because sometimes the cartoons or whatever you want, the pictures, the drawn pictures don't really make that much sense. And other times you see it physically and you're like, oh, okay, I get it. Sometimes both help. This is the temp gauge. So your purple wire from your dash, from the sending unit, the exact same thing, except for a 1000 ohm resistor, right? But same wiring as the oil. Here it is again, the actual physical one. Oh, it looks like a mess. It is a mess, but again, I've never touched an Arduino or anything before this. And you know what? If you look to the right on the screen, you can actually see where I heat shrinked on the actual screen plugins. I was telling you and I didn't show it, but right there you can see the heat shrink and the little tan of the capacitor poking out through there. And then the fuel gauge. Fuel gauge is kind of like the oil gauge, but the different wire color, obviously from the dash, it's the brown, but 100 ohm resistor again. How I chose these resistors, I will tell you. Again, I had help with this, and I'll go over that later on. And there it is. There's my my actual fuel gauge. So here's how I did the capacitors on these guys. Basically wrapped it around one of the legs with a spliced wire on each side, heat shrinked each leg of the capacitor with the wire, and then I heat shrinked the whole entire thing, right? So like I said, I've been going for this for a while and I haven't had any issues. Here's how I did the resistors. Kind of the same, not even kind of, it is basically the same, just different shaped. There you go. And this, what I actually ended up doing, you'll see me, I cut this really short. I didn't end up doing that. What I did is the exact same thing as I'm doing, except for I kind of modified it on towards the end. And that's where I would cut the little leg of the resistor longer and then fold it down. But, you know, whatever. I mean, again, I tried to Google this to see how to do like inline resistors and stuff. And maybe my wording for Google was clunky. I didn't really get that many good pictures or tutorials. So this is what I came up with. And then just heat shrink it. Like I said, just kind of like the capacitor. Now that we have the hard wiring out of the way, we have gauges that basically don't work. They look cool. They're pretty. Yeah, you can shove them in the dash and you're like, oh man, that's freaking awesome. But now we got to get into the weeds of the programming. I'm not going to go over like the Arduino IDE, which is the program that you use to write all the code. You can Google that. If you buy that kit that, for beginners, it tells you how to download it. It kind of teaches you the ifs, what to do, how it works, like where to put brackets and parentheses and all that kind of stuff. Not really that hard to do. You'll have a lot of help, which I'll go over in the end. But I'm going to go over basically like the basics of how Arduino works in this aspect for a gauge, right? So it's a 10-bit resolution little microprocessor, and it uses what they call ADC, analog to digital converter. And so 0 volts equals 0, 5 volts equal 1023, right? So you have that window of 0 to 5 volts and 0 to 1023. That's what it can read. So the formula is voltage equals reading times 5.0, 5 volts, divided by 1023, right? Hopefully that kind of makes sense, and I'll explain it a little bit more. So let's take an actual code. This is my actual oil pressure code. And the map sensor, that's the AO, is reading, and it's mapping the analog read, see, AO next to it, of not 0 to 1023, but 0 to 484. And I'll explain that. And so it pumps out the 0 equals 0. This is why I chose this sending in it, because it's very simple. And so then it pumps out 0 to 80 psi. So when it reads 0, it's 0 psi. When it reads 484, it's going to read 80 psi. The 800 equals 80 because it's 80.0. But so if it reads like, let's say 250 or 260, right? Whatever. That's somewhere in the middle. So it'll read 40 psi. So literally it's taking that raw reading of the 0 to 484 and converting it, doing that little 5 volts divided by 1023 or whatever, and kicking it out to whatever we set. So if we change that from 0 to 800 or 0 to 80 psi, if I put, let's say 500 at zero reading to analog read to the nano, it wouldn't kick out 0. It would kick out 500 because that's where I told it to begin. So there's windows to work within, right? And hopefully you grasp in this. Again, I barely grasp it. You can probably tell it in my voice. So here's where I try to draw it out. And explain it again, but physically. So we have the oil sending in 0 to 90 ohms. It runs into the 5 volt power that goes into the 100 ohm resistor. That's that pull down resistor, right? It switches it to the AOC, not to the AOC. Oh, wow. Okay. Anyways, it switches to the ADC, analog digital converter. There's our range, the 0 to 484. The full window that the Arduino can read is 0 to 1023. But because of that 100 ohm resistor mixed in with the 0 to 90 ohms, it's only going to read 0 to 484. And this will help you out, trust me. There's a reason I'm going over this, so you learn kind of the basics of it. If we add in if we get rid of that 100 ohm resistor and we add an XYZ ohm resistor, I don't know if it had to be higher or lower to make this happen, but anyways, we can expand the window that it reads. So it now, then with the new resistor, it would read 0 to 650. The reason that's important, and the reason why Arduino is so cool, among other things, is you can literally make your gauges as precise as you want, or as clunky as you want. It's the 3 little bears in a porridge. There is a good median in between, because if you make what you're doing is you're fighting the interference again. Remember that car ecosystem with the capacitors and all that jazz? You're fighting that. And even sending units can get kind of jittery and have spikes and stuff like that. So if you make it too broad and you're like, I want it down to I want to know, down to the double decimal of whatever, 79.65, and you make it too broad, you might get some interference. But if you make it so an EMP can hit and your gauge is still reading it because you put in a resistor that shortens the window, it's going to be super safe. It's going to read anything. But the problem is that the window is so small that it won't be 0 to 650. It'll be like 0 to, let's say, 100. And so literally, or maybe 50. And your gauge won't read like 66 or 68. It'll read like 0 psi, 10 psi, 20 psi, 30 psi. But I mean, you could throw whatever you want at it electronically and it'll survive. It just isn't that great of a gauge. So that's why there is a sweet spot of these resistors that you use. And so, and it can get kind of complicated when you have, that's a very linear sending unit. Linear by 0 equals 0 ohms, right? 0 ohms equals 0 psi. 90 ohms equals 80 psi. There's not much variation there. It can get nuts with like the IAT, I think, and also the temperature. I don't know. I forgot. But like there's one where it's like 1,000 ohms, and then 800 ohms it goes down to is only like 10 degrees. But then when it goes down to, and say that's at 200 degrees, right? So it'll go down to like 190 and it'll skip like 200 ohms. And then it goes all the way, when it goes down to let's say 100 degrees. When it changes that same 10 degrees, due to changes like 5 ohms. So it's kind of more like half a bell curve. And to map that out, it's freaking insane. Like the little 5 volt divided by 10, bro, it's nuts. And that totally actually threw me off. I had issues with it. And so you're probably thinking well, how did you figure it out then? How did you make this? Because you're like barely grasping onto this. So, did you become like a genius overnight? No. I started Googling it. I didn't find the answers I needed for where to start resistor wise and all that. And I'd never used AI before. This is like such a learning experience, this whole entire thing. Never done Arduino, never done coding, never used AI. Like literally, I've never used it. I used it for the first time. And I treated it like a Google search query, right? Where I was like, hey, what would this do? How does this work? And because if you go on like Arduino forums, the guys are super smart, but you'll get stuff like, well, why would you do that? Like, what's the point of this? And it's just like, bro, you know what? Because I want to dick around, because that's the point. Because this is America. That's why I just want to do it. Okay. Don't worry about what I'm doing. Just tell me the answer. But sometimes life isn't that easy, or, you kind of get an answer and you're like, well, that's not exactly what I needed. So I still don't know what resistor to use. You know what I mean? So I asked AI, and one thing led to the next. It told me answers, because I had troubles figuring out the resistors, and also which resistors to use, and also how to map them into that ADC, so that into those windows, right, that I was explaining, so that it kicks out onto the screen. So right here is one exactly. This is 1,000 ohms equals 189 degrees, down to 330 equals 259 degrees. Like, bro, what? So, and I started, and then it was like, I was like, well, I'm working on gauges and for a Jeep YJ, and it was like, oh, cool. You want to do all of them? And I'm like, I mean, I guess, like, okay, Google AI, you know. And it was like, cool, let's do a fuel gauge. And so at first I was like messing around. I was like, hey, you know, here's what I have in my code, and was like, oh, you need to change this to that, and, you know, plug in like this part. And if you ever, when you start doing this coding, you're like, bro, I don't know, I'm kind of lost as to where that starts or where that begins. And I did it that way, and it was kind of clunky. And then eventually I was like, hey, can I just give you my whole entire code? And it was like, sure. So I literally copy pasted my whole entire Arduino code, threw it into AI, and it was like, oh, here, you got to change this. And I was like, can you give me the full code? It was like, yeah. So I just literally just copy pasted back and forth between my code on the actual Arduino and between its code that AI was pumping out. And then it started asking me stuff like, hey, for your fuel gauge, do you want a warning light? And I'm like, yeah. I'm like, I mean, no offense to you, but like I said, he does a great job. I'm like, he didn't have a warning light because he wasn't doing a fuel gauge. And so then AI was like, oh, cool, I'll put that in your code. And it worked. And then it was like, do you want slosh? And I'm like, what do you mean by anti-slosh? I was like, you know, so like when you hit a bump and, you know, you got waves inside the gas tank, your Arduino gauge isn't like jumping all around with the waves. I was like, yeah, okay. It just gave me all this crazy stuff, like perfectly. And, well, not perfectly. Most of the time it was good. And honestly, there was so much back and forth of me using the wrong resistor because I couldn't, the little ribbons that you buy it on, and it says like 2K2 and 2R2. It was very hard for me to realize if AI was messing up the code, or if I was messing up the resistors or something like that. But like, for instance, it will help you troubleshoot. It will literally give you on bench testing, hey, it'll teach you how to simulate a sending unit. So our 0 to 90 example of the oil. So you have it all hooked up. You hook it up to your bench testing, you know, your little 12-volt battery you got on the bench, and your Arduino is reading nothing because it doesn't have a sending unit, right? So it'll read zero psi. Well, to test it, you grab something like a 22 resistor, and it thinks that 22 ohm resistor, it thinks that is the sending unit sending 22 ohms, right? So it should read about, I don't know, 25 psi. And Google AI was the one that told me to do that. How to bench test the fuel, how to bench test oil pressure, this, that, and the other. So AI is how basically I got here. Told me what resistors to use because it scours the internet, says, hey, you have a Jeep YJ, you're using this sending unit. Like, you know what I mean? And there's multiple different sending units that can be found in Jeeps. But nonetheless, it gets you there. And if you tell it, like, hey, I'm running into this issue, it's like I just lasered it, you know, like temp, right? If your gauge says 160 and you laser it and you're like, yo, my temp is actually 186, tell AI that and then plug in your code and it can adjust it. And then it's up to you to check it, you know what I mean? Or just look at, if you're okay with it and you're like, all right, it says 165 and I'm really at 180, you know what I mean? But you know it's on point. So if it gets to 180, well, in reality, that means your Jeep's at like 200 or something like that. You get the gist. So that's the cool part about making your own Arduino gauges. Now, hopefully you guys got a good grasp on that and can kind of jump off from there. And if you have any questions, like, leave it in the comments. But now, here's the crazy part. So I got to thinking, I want to make some stuff that moves. And I was like, well, wait, is this how like cars have light sensors? You know, like when you drive in a garage and your headlights automatically turn on? Because I was like, I mean, I always assumed it was all 12 volt. Well, dude, check this out. My IAT that I bought, it's a 5 volt. And you know why? I had no idea about this, like literally no idea, because ECUs use 12 volts, but a lot of the sensors, like the MAP, the mass airflow sensor, the TPS, the O2, is all 5 volts. It's so any of it can be put on an Arduino. So what I'm getting at is that you could, all the cool stuff, like when a Porsche is hauling ass and it hits 80 miles an hour and all of a sudden its airfoil wing comes up, and you're like, bro, that's badass. You know what I mean? That is, they probably don't use an Arduino. Maybe they do. I don't know. Probably not, though. It's Porsche. Come on. But you can make one. You can even, and using a transistor, an Arduino is 5 volt, so it has the brain, but it's very weak. Yeah, it can run gauges and little dinky stuff. You know what I mean? Stepper motors and all sorts of stuff. But when you start to hit things like wind resistance, right? Bro, your little 5 volt Arduino just ain't, and its little stepper motor that you got in the kit, it ain't gonna do it. What it can do is that Arduino reads your RPMs or whatever you want, right? It reads a light sensor and it's like, oh, I'm in a parking garage, and I don't know. Let's just get stupid. Let's say you want your airfoil to raise in a parking garage. I don't know why you did that, but you can. Okay, and so it would read using a little $5 light sensor you bought on Amazon. Plug into our Arduino, right? Try writing the code, have AI write the code, whatever you want to do. And then when the Arduino uses this little sensor, this little 5 volt sensor, and says, oh crap, dude, like there's no light. It clicks to a transistor, which is kind of, it's like a baby relay that then tells a larger relay, hey motor, do XYZ. Airfoil will come up in a parking garage. So what I'm getting at is that's a stupid example, but there is so much that can be done. Arduino has thermal cameras, they have proximity sensors. There's so much to be done with an Arduino, and that has been done that I just didn't realize exists in the world, and maybe you didn't either. You know, a TPS, or all position sensor? All right, not a big deal. A lot of cars come with them. But if you're a carb guy and you're like, man, I really want that Holley throttle position sensor, but $200, bro, all it is a potentiometer. A potentiometer changes the ohms as you turn the dial, right? You saw it on my little dinky, the little kit I got, and I made the little fuel gauge, whatever. If you hook that up to your throttle body on your Holley and you wire it to an Arduino with, basically, you just made a sending unit out of a potentiometer using your throttle and the position, you know, as it turns the potentiometer, and you hook it up to a screen. Now you have a TPS. You have a TPS. Like, and that TPS, you can also put in the programming where when I hit X, X amount, like let's say 75% throttle, I want nitrous to kick in there. Bam. There you go. Or whatever, methane, whatever the hell you want, man. Again, airfoil. If you want your headlights to turn on, you can do it. I know I'm getting ridiculous, but like, I'm excited because I didn't know any of this stuff, and maybe you did, and you're like, yeah, dude, we got it. But that's insane to me. So I have a whole bunch of different projects I'm going to do. I'm going to do the IAT. So anyways, enough rambling. Hopefully this inspired you to simply make a gauge or do some other crazy stuff, sensors. If you rock crawling guys, and you guys, or if you drag on your, when you're flexing, you drag on your fenders a lot and you're tired of ripping up your fenders, dude, put an Arduino gauge and some proximity sensors. Like literally it'll start flashing when your tire gets too close to your fender. There's tons of crazy shit that can be done, right? Hopefully you enjoyed this video and you got something out of it. And if I missed something, let me know. I can put in, I can do a short or something like that to explain it. And I don't know, man. Hopefully the world's your oyster now. Hopefully you feel that way. All right, guys, enough ranting. I'll talk to you later. All right, and like, subscribe, all that good stuff. We're gonna try something. I keep talking about the AI and this, that, and the other, and the IAT. You know what? It hit me. I haven't tried the code. I haven't done anything with my IAT, literally straight out of the box. And I kind of rigged this up just for right now with a little Arduino Nano and a battery. And we're going to test the AI bit, right? Like I said, this is a kind of a test, and also just to see what AI can do, because I just did a video on it. Where the heck is AI? Let's just start over. AI mode. Okay. Arduino SSD 1309. And would like a gauge for IAT. I already looked it up. Okay. IAE. Okay. It's right here. Let's make sure we got it right. 250, 36, 751. Okay. Yep, that's right. All right. We'll just copy and paste it. Boop. Let me open up an Arduino, because I'm going to need... The Arduino program is kind of weird. You can't it's not like Windows where you can just right click and then open up an Arduino program. So anyways, we have to make sure that we include this library. Copy. Please use this library. And do we want it to... Yeah, we'll do some logging. Logging on the screen. Thanks. A copy. Oop. Copy and paste. Ready to go code. Oh, it already did. Okay, well, whatever. Pull up resistor 2.49. Okay, so there's a 2-wire sensor. This is... most of the Jeep ones, the stock ones, are 1 wire. This is because an IAT usually gets put into plastic, so it can't ground itself, unlike our old school sensors on the YJs and stuff. Pin 13. Oh, okay. Pin 13, pin 11. I don't think I did that. Hold on. I'm going to tell it to change it. Please change SSD 1309 to pin... What were we using before? Uses A4 and A5 to pin A4 and A5. This is I2C. Okay, let's see how it works. I'm gonna let's see what do we need? 2.5 resistor between 5-volt and AO pin. Under resistor. Okay. Oh, I don't have 2.5. Okay. Okay. All right. Now, actually, I'll plug in the so you can see this little Arduino is still programmed for the fuel, right? So we will do 5 volt, and oh boy, this is going to be tough. AO to 5 volt in. Yeah, rehook back up our power, and our gauge will go to AO as well. And let's see how we do. We have to still upload. All right. So scroll all the way down, copy, get rid of all of this. Oh, sorry guys, I drew a little low. Bam. Let's make sure it all works out okay. Uh-oh. Oh, board. Because I had my... You have to select the port. Now, again, when you get that little kit, it tells you all this stuff. What's happening here? There we go. Plug them in. Nano's in, COM10. Okay, that was... See, there you go. That was my mistake, I think. And let's see what it does. Ooh. There we go. Now, you see how it's like a little sketchy? And it's in Celsius. So, we go back. The numbers are changing too fast, and I need Fahrenheit. Yeah, it's going to spit out some help. Fahrenheit and smoothing. Let's try it. Copy. Paste. Bink. Still more smoothing. Let's see what it does. And it is not 128 degrees in here. So I'm going to say it's, oh, sorry guys, about 80 degrees. Okay, let's try it now. Okay. So it's 108, 109. Well, I'm not boiling. So numbers, no decimals. It now says 109 degrees. Should have said whole numbers, not solid numbers. Whatever. See how it does. Copy. Paste. Okay, we got an error. See, it messes up too sometimes. Okay. What the hell's going on here? Now it says, now we're pretty good, but now we're stuck on negative 40. So we're missing some sensor pins. Confirm one side of the 2-wire sensor goes to the AO, the other side to the ground. Yep, one side is to the ground. Tell you what, we're going to, I use the ground on a breadboard. It's a little loosey-goosey. So we're going to go exactly to the ground of that guy. And pull up resistor, ensure your 2.2 thousand resistor is bridged between 5.0. Oh, you know what? I had it in the voltage in. This is where I said it'll help you. Okay. All right, let's go back to it. The monkey with the machine. fixed. Resistor now says 233 degrees. It was previously in VIN. There's a huge fix. Okay, when it was in VIN. Okay, well, it thinks we were, I think. Okay. Copy. Paste. There we go. Check that out. 84 degrees. We got a log, right? Now I'm going to put it under its own power because right now it's hooked up to my computer. We're still at 84 degrees and we're going to, I don't know exactly how cold it is in my shed, or actually more so how warm it is. So I'm going to carefully carry this and you guys over to my AC. And we'll see what it says. It's going down. I'm gonna grab my thermometer doohickey. Let's see what it says in there. 63. There we go. So remember, because I told it was 80, and I don't really know how warm it is in here, to be real honest with you. The aluminum says 73. I have an aluminum intake. I guess that would be close to what it is in here. That says 75. But nonetheless, so I kind of threw it off because I don't really know exactly where I'm supposed to be. But that's pretty cool, huh? And we have a logging. Now, let's go one step further. That log kind of looks like crap. So, move you guys. Let's see. I want a graph. That's what I want. Great. Can you please use all of this code, but change the logging to some type of graph? Use your imagination. Okay. Scrolling sparkline graph. I don't know what the hell that is. All right. We're going to take off its own power, hook it back up to the computer. You're not supposed to have external power hooked up while it's hooked up to a computer power. I've done it before, but it's not good for the Nano. Not good for the little guys. All right. Same thing. Copy. Let's see what this one looks like. Paste. Send to the Nano. The Nano is blinking. Whoa. Oh, bro, that is wild. Do you see the little, oh man, that's like super tiny. Do you see the little graph? And I'm assuming that this goes up as it goes colder. Again, this is literally 5 seconds. Not 5 seconds. I don't know how long you guys have been here. How long I've been filming for. It's under its own power now. Well, actually four AA's. And let's see what we got now. Oh, at least it was. Oh, I accidentally pulled out the power wire. Because I just kind of got rigged in. There we go. Oh, I'm trying not to mess up that power wire. Oh, well, he just fell in there. So he's going to get really cold. Okay. You see the little graph? All right. Well, nonetheless, I don't really like this one either. But as you can see, you can use AI from scratch. And I mean, if you don't like, just keep on having it, make it cycling through graphs. If you don't like the graphs or the gauges, right? That was the whole entire point of me hopping on. Like Bill Riley would say, we're gonna effing do it live, and there you go. So just to prove the point that AI with a little bit of help, and as long as you do your part, like how I had the resistor ass backwards, it'll get it done, dude. It'll get it done. All right. And as you saw, no knowledge basically from my part except for knowing the part number of this guy and knowing how to be persistent. All right. Thanks, guys. Like, subscribe, all that good stuff. All right. Bye.